Alright, welcome everyone. This is going to be a short introduction video to EPANET 2.2. This is specifically for CE 313, Oregon State University. For the hydraulics course, we're going to be using a little bit of EPANET to help us solve some piped flow problems. And in particular, the goal of today is to be able to use EPANET and know how to use it to solve something like this, which is some of the problems on homework 2. So we're going to have a reservoir and a pipe leading to some houses that are going to use some water. So we want to determine the pressures, specifically here at A by the homes. And then this problem is determining the flow between two large reservoirs through this pipe. So the goal, I'm not going to solve these exact problems, but I'll show you how to set up problems just like these, and then we want you to play around with EPANET, solve these by hand, and then solve them in EPANET and see that you'll get the same thing. So that is the goal of today. Alright, so let's go back to EPANET here. EPANET is, a free open access software developed by the EPA. It's used, pretty commonly, I'd say mostly in research and other spaces because it's, it's free. But because it's free, it's not going to be the most intuitive to use in my experience. But luckily, there is great documentation that will answer basically any question you have about what assumptions EPANET is making, and just to make sure that what you're putting into the program is what you think you are doing, and it gives you the right answers. So I'd encourage you all to Google EPANET documentation. There'll be this website, readthedocs.io, for EPANET 2.2, which is the version that we're using. This is going to be your best friend if you have questions. We're going to use this a lot. For example, a big hang-up I think with EPANET is knowing what units it expects all of the values in. So if you just search for units, or if you go to your appendix, this is what I want, units of measurement here. So it's going to ask for all of these things, and it's not going to tell you which units, so this is going to be really useful for you. And then there's a ton of other stuff. There's a quick start tutorial. Really any question you have will be in here, so if there's something I don't cover, look here first. Alright, so let's go back to EPANET. Just wanted to get that out of the way. Alright, here we go. So this major screen here that I'm moving around is called the network map. This is where you're going to draw your system. It's going to be a 2D drawing with little figures, and then the lines connecting them will be the pipes. So I'll show you what that looks like. And then over here, you've got your browser, which is going to give you a lot of options on how to view all the things in your map, all your junctions, reservoirs, and tanks. And then also another way to get at options that we'll see. But you can also get at these options through the project analysis options, right? So there's just multiple ways to look at things. All right, but you can move these around. So if they're not to your liking, please, you can shrink them, make them bigger. You can't do that for the browser, but all right, let's get started. So first, I would always suggest going to project analysis options. This you can also get to in the browser window. If you go to options here at the bottom, here's all the things. See, if you double click, it'll bring up the window. So let's try that. Double click. Boom. Here's all your hydraulic options, and then options for everything else that you'll eventually use as you get more into EPANET. But for now, we're just going to look at hydraulics. So this is where you're able to set what units you want to use. So let's see, for this first problem that we're solving, bringing this back over. All right, it's giving us demands in liters per minute. So we're in metric here. We got 30 meters, 1 kilometer, right? So we're in metric. So let's look at flow units. Okay, it gives us tons of options. GPM, gallons per minute, right? I think this is million gallons per day. Okay, liters per second, LPS, liters per minute, LPM, okay? So that's the flow that we want. Then this one is asking us for what head loss formula we want to use. So H-W is Hazen-Williams, D-W is Darcy-Weisbach, and that is the one we're going to use today. So, oops, right, that's the one we want, Darcy-Weisbach. Okay. All right, and then this gives us a lot of other settings. So like we can set the specific gravity. EPANET assumes water at its most dense, which is about 4 degrees Celsius. We don't really need to touch that for these. Maximum trials, and this is all stuff for it, how it solves the system of nonlinear equations. But we don't need to touch any of this here. But if you're curious what all of these mean, again, go to the documentation. It'll explain what these settings mean. But for now, we just need to change flow units and head loss formula. Make sure that it's liters per minute in Darcy-Weisbach. All right. Now that we have those set, we can start building or drawing our problem. All right, so let's tackle this first one. So we have, this is a water tank. It's telling us that the pressure in the tank is 0. And then we have a kilometer-long pipe from the water tank to these houses where we have some demand. So let's set that up in EPANET. So we want, a reservoir, a tank, a pipe, and then a point of demand where water is going to be taken from the network. All right, so let's go up here where you can start to add things to your map. So you can add a junction, so that's a point of demand, or it can just be connecting different pipes. For example, if you have a T and you want to connect 3 pipes, you would use a junction. A reservoir, tank, pipe, pump, valve. All right, and then a label. So we won't deal with pumps and valves today. We're just going to stick with pipes, tanks, reservoirs, and junctions. And really, actually, we're not even going to mess with tanks. So the difference between a tank and a reservoir in EPANET, I'll show you. So if you click on the symbol, and then you'll see your cursor's changed to a little target. And if you click once, it'll just auto-pop, it'll create a reservoir for you. And you want to go back to your select object tool to give you back this cursor. If you click and hold, you can move it around, and we don't need 2 of these, right? So if I click it and it'll start blinking, that means it's selected. I can just hit the delete key, or I can right click and hit delete, or I can go right over here in my browser, data, go to reservoirs, and this is showing me my 2 reservoirs that I have on the map. It auto-labeled these, R-1 and R-2, and if I double-click on it, it'll show me its properties. So I have these set up to auto-label my reservoirs and items with a specific convention. And yours, I think, by default, it'll just label these as 1 and 2. It won't give you R-. So if you want to change that, I like changing it. It just makes it a bit easier. Go to project defaults and then ID labels, okay? So I think by default these are all just blank. So what I've done is when you create an object, EPANET has to give it a name, something which it can identify it with, and it has to be unique. And if, for example, I think by default it just labels things as 1, 2, 3, 4, right? A reservoir could be 1, and then a pipe could be 2, and then a tank could be 3. So it just gets really messy. So I like doing these specific prefixes. So for all junctions, they'll start with J dash, and then it'll give it a number. So J-1, J-2. This is not important for this problem, but as you get into bigger systems, this will be really important to keep you organized. So I apologize for getting into this now, but I just wanted to explain why your EPANET might look different than mine. All right, so that's where you can set these and then save them as defaults for all your new projects going forward. So I really recommend doing something like this to keep yourself organized. All right, so going back to the problem. All right, reservoir 2, we don't need that, so let's delete it. Okay, so we added our reservoir, and I wanted to show you the difference between a reservoir and a tank. All right, so here's we have a tank, it's this symbol, and a reservoir is this symbol. A reservoir in EPANET, excuse me, always has, just like we assume in problems typically, no pressure at the top, right? Atmospheric pressure, it's not being contained. And really, a reservoir in EPANET stays at a constant level. It assumes a very large reservoir, so you're not going to drain out your reservoir. It's always, if you set the elevation or the total head, let's say it's at 100 feet, right? From, our zero, whatever we want our zero to be. Say it's, 100 feet above our datum, so it's going to provide 100 feet of head, and, you can't run out of water. So that's how EPANET assumes reservoirs operate as. Okay. Tanks, on the other hand, can run out of water, so they can fill and then empty. So tanks, you have to add more things, right? You need an elevation, so what is the water level at when the tank is empty, right? And then you have to set the initial min and max level. So, right, if it's a 40-foot tank, where does the water start? Is it 10 feet up, 20 feet up? Minimum level is how low can the water go. So it's at 0, means it can fully empty. Max level is obviously how high the water can go, right? If it's a 20-foot tank, it can't be higher than 20 feet. And then diameter, it assumes tanks are circular, so it needs to calculate the volume of water that the tank can hold, so that's why it needs a diameter. And then these can get more complicated into water quality and things like that. But for now, these asterisks mean that's what's required. Everything without an asterisk is not required, so we just need these things. Luckily, these problems, we don't need to set up a tank, so we're going to ignore that for now. All right, we'll just work with reservoirs and pipes and junctions. Okay, so we've got our reservoir, and we need a point of demand. So we're going to go to junction, create a junction. All right, so now we have a reservoir and a junction. Now we need to connect them with a pipe. So we go up here to add pipe. Click once on your reservoir. Then if you move your mouse, you'll see it's going to start drawing a pipe. You can just hover directly over your pipe or your junction, and if you click again, all right, now your pipe is created. You can't just create pipes. It has to be, you have to create the junctions or reservoirs first. So see, if I try to create a pipe here, I can't complete the pipe until I'm going back to either a reservoir or a junction or a tank. All right, so here I've got my reservoir hooked up to my junction. So it's starting to look a lot like this, right? We have a reservoir and a pipe to a point of demand or a junction. So now we need to give the properties to all of our items. So here our reservoir, right, in the problem it said 30. I'm not going to solve the problem for you, so let's just say we have 50 meters of head. And then right here, so this is what I was saying earlier, right? Total head 50. 50 what, right? We don't know, it doesn't say. And so this is where we have to consult the documentation to see what EPANET thinks we're doing. So coming back here to our documentation, go to appendix units of measurement. So how EPANET works is you set your flow units, right? We saw we could do gallons per minute, gave us a bunch of options really, but we set it to liters per minute. So EPANET, once you set your flow units, it assumes you're doing US, customary, or metric. So since we sent it to LPM and liters is a metric measurement, it's going to assume everything else we do is in metric. So, right, our diameter of pipes it wants it in millimeters. The diameter of tank should be in meters. Efficiency should be a %. Elevation is going to be in meters. Okay, so this tells us everything that we should assume, right? So our flow is LPM, liters per minute, okay? So if you do any of these flow units, it's going to assume everything is in metric. If we chose GPM or CFS, it would assume everything else is in US customary, okay? So we're in liters per minute. We're trying to set the elevation or the head of the reservoir. So if we go here, our parameter elevation, okay, should be in meters, okay? So total head, right, that's an elevation, 50, perfect, okay? So our reservoirs, that's all you have to do, it's set up now. All right, so again, you can get to those properties by double clicking or by going to browser reservoirs and double clicking here. All right, so now let's edit the properties of this pipe. So again, if you click on it in the map, it'll start blinking. That means it's selected. If you double click, it'll bring up the properties. Also, the properties can be brought up with, if you go to pipes and then double click here on P-1. All right, so here we go. Gives it the name, ID, the start and the end node. So it's starting here, reservoir 1, R-1, and it ends at J-1, this junction. So perfect. All right, length. So again, you know, 1,000 watt. So let's go back here, right? Let's see if we can find it. Length should be in meters. Okay. So there's a lot of doing that, and eventually you'll just know what it wants. So I think originally we said this is going to be a kilometer. I don't want to do the problem for you, so let's say it's half a kilometer, which is 500 meters. Okay. Our diameter should be in millimeters. So let's say it's 150 millimeters, okay? So again, right, we double check that, diameter, pipes, millimeters. So you gotta be really careful here. Cool. Roughness, again, so what units do we want the roughness in? Here we go, roughness coefficient. So usually it's unitless, right, if we're using Hazen-Williams, but for Darcy-Weisbach, it's not unitless. So for metric, which is what we're doing, it wants it in millimeters. Okay, so, oops. So, let's say galvanized steel has a roughness coefficient of 0.15 millimeters. So let's go ahead and put that in. Great. There we go. Now I think that's everything that we need for our pipe. Loss coefficient, this is where you can add minor losses, but we're not going to do that today. And then initial status is where you can have the pipe open or closed, or CV means check valve. So a lot of pipes, especially around tanks and where you don't want backflow, right? It's going to have a check valve that only allows flow in one direction. So if we wanted to, we could do that. But again, that's not really needed for this simple problem. All right, that's all good now. So, right, we can, all right, I was just moving this around. If you click and hold, you can drag it around. Cool, great, now we have a reservoir and our junction. So, there is actually one more thing I forgot to add. So if we go back to our junction, oh wait, so we did the reservoir properties, the pipe properties. Now we need to set the properties for our junction. Okay, so elevation. So if we go to our problem, you know, it's not, I'll just show you here. It's 30 meters, right? So our elevation here is 0. So leave that at 0. Base demand. Okay, so we selected all flow units to be liters per minute. Let's just say our base demand is 300 liters per minute. So that's, you know, when this is simulating, it's going to assume that's what is the amount of water that will be withdrawn at that junction. Okay, and everything else we don't really need to set right now. We'll go into some of this later. Okay, so that's all we needed to do. Now we're ready to have EPANET run our simulation. So if you go here, there's this little electric bolt. If you hover over it, it says run. So this is going to run a simulation. Before we do that though, let us check the settings for it. So if you go to project analysis options, or maybe that's not what we want here. Right, so let's go over to the browser, go to data, and then select options. So quality and reactions, we're not doing times, so let's look at times. So double click on times. So this is where you can set how long you want your simulation to run for. Right now, and for most of these problems, we're going to do a steady state simulation. So that means we're not simulating the network, through a day or through a couple hours. We're just going to look at it, simulate it for like a snapshot. So durations is set at 0, I think by default. So when this is set at 0, that means it's going to do a steady state simulation. All right, so we don't have to look at any of these other settings because this is for an extended period analysis, which we're not going to do. So I wanted to show you where you do that. All right, so now we're finally ready to do our simulation. So you can go to this bolt and click it, and it will run, and it said it was successful. You can also go to project run analysis, right, and it'll tell you that the run was successful. All right, and this shows you what time you're looking at. So, right, it's a steady state, so we're just doing day 1 at midnight. This doesn't matter. So now, how do you look at your results? So if you go over to your browser and click on from data to map, this will allow you to select what metric or variable you want to look at in the map. So for nodes, right now it says no view. If you click on that, if you click on elevation and then hover over these the different points on your map, it'll tell you what elevation it's at. So this is at 0, hover over here, that's at 50, and it gives us the units there. Let's say we want to look at base demand. Let's click on that. Base demand 300. Okay, NA, right? Reservoirs don't really have a demand. Right, so we can look at all these different things. So let's look at pressure. Okay, so pressure is going to be a really important one. So let's click on pressure. And this gives us a key. So the pressure here, reservoirs 0, right? It's open to the atmosphere. Okay, the pressure here is 49.66 meters. So this is giving us pressure in terms of head, right? So if you wanted it in terms of maybe kPa, you would have to multiply, right, by a specific weight of water, which you could do. But for now, and typically in metric, you look at pressure in terms of feet of head. So this is at 50, right? The reservoir is at 50 meters high, and then it goes through this pipe and loses not that much head, right? It's only a point, what is that? 3.34, right? 0.34 meters of head that it loses. So not a lot. And for a problem like this, right, that's really what you wanted, right? The pressure in meters of head at this point. So there you go. It's that easy. Links, you can also look at lengths, diameter, roughness, flow, velocity. You can look at the unit head loss, right? That's interesting. We're losing 0.67 meters per kilometer. You can look at the friction factor, right? It calculates it for us at 0.025. We don't have to use the Moody diagram. You can look at velocity, which is also a pretty important one in water distribution networks, 0.28 meters per second. So a lot of things to look at here. Very cool. All right, so that's how you set up kind of that simple reservoir to demand junction problem. Cool. So this is becoming a long video, but I just want to touch on the last problem here. So now let's go to this one, where we want to look up for to calculate the flow between two reservoirs. So this is a little bit harder to do in EPANET, but we can. So let's go ahead and delete all of this. Right, and then you can also use this, select region. You can click out a little box, right click to finish, and then delete everything, right? So if you wanted to do that quicker. All right, so let's set up two reservoirs and try to figure out the flow between them now. Let's go back up here to our reservoir icon. We're going to add 1 and then 2, and then we want to add a pipe between them. So add pipe, click, and click. Great. So now let's input the properties for all of these things. So if we look at this homework problem, okay, we're shifting to US customary, right? Inches, feet, flow. Okay, so we need to switch our units here. So let's go to project analysis options. All right, so we're in times. We want hydraulics, so browser, hydraulics, double click. All right, let's do, if we scroll up, let's go to CFS instead, right? Cubic feet per second. We're still using Darcy-Weisbach, so that's still good. Okay. All right, now let's give us, let's give the reservoirs their properties. So this reservoir is supposed to be at 100 feet in head. All right, and let's, again, we got to go back to EPANET's unit of measurement to make sure we're in use customary now. So elevation, it does want feet. Okay, great. That's what I would assume, but you have to double check here. All right, feet, perfect. So that's all we needed to do for that one. This reservoir is a lower one. I'm not going to do the same elevation as the problem. I'll just say this is at 10 feet. Okay, so that's all you have to do to set up the reservoirs. Now let's set up the pipe, double click on it. Okay, length, I'm assuming it's also feet. Yep, foot. Okay, let's go back. So the problem says 7,500 feet. Let's just say we're at 5,000 feet instead. The diameter, let's see, pipes, inch, okay. Right, so this is sort of annoying. Let's say it's 8-inch pipe. No, let's say 6-inch pipe. Roughness, so we're still using Darcy-Weisbach. So let's scroll down, roughness, Darcy-Weisbach. Okay, this is kind of annoying. So it's in feet, but it's in feet times 10 to the -3. Okay, so we're going to have to add, basically multiply it by 1,000 before we put it into EPANET, which when I was first setting up this problem was, I did not know that, and it caused a lot of problems. So roughness here, so let's say rough concrete, right, that has a roughness coefficient of 0.01 feet, right, but it wants it in feet times 10 to the -3rd, so we have to multiply that by 1,000, so move the decimal over 3, right, so that should be 10. Okay, all right there, so that should give us the right answer. Okay, so now if we hit simulation or run, it's going to give us an error. So the run is unsuccessful. Okay, error, not enough nodes. So this is sort of the workaround that you're going to have to use. So EPANET won't run unless there's at least one junction or node, right? They're sort of interchangeable words. So, okay, so let's add a junction or a node and connect it into the network. Okay, so that's not in the problem, but EPANET won't run unless we have a node here. So, right, let's in order to get this accurate, we don't want there to be any flow, so we can leave the base demand at 0, right? For the junction, we don't want any flow going to it. And then it really doesn't matter what this pipe is, right? Because we could even close it, because this pipe, we don't want it to do anything. So now if we hit run, okay, look, run was successful, even though, right, nothing's really changed. There's no flow in this pipe. We closed it, and there's no demand at the junction, so it's not doing anything. And if you go to map, links, flow, and check it, right, 0 CFS. There's no water going through this pipe. It's closed. All right, but if we go to this pipe, oh, look, it's telling us what the flow is, 0.67 cubic feet per second. And if we want to look at the velocity, we could, 3.44 feet per second, or let's look at the friction factor, 0.049, right? This tells us a lot of information just at a click of a button. And this problem, right, is asking for the flow. So pretty easy right there. All right, so this is, almost a 35-minute video. But, you could really do this in about a minute if you know what you're doing and feeling comfortable with EPANET. All right, so thanks so much for watching. Good luck on your homework. And yeah, we're going to do a lot more EPANET in the future. So I think this is a great intro. Please investigate, play around with diameters and roughness. You can really get into it. So thanks so much for watching. I'll see you in class.